Okay, so here's that moment we've all been waiting for. We're actually going to start the unit circle. We're going to start doing the unit circle right now. So here's trusty unit circle that everybody's got a copy of. So you're thinking, I can't fill this in. This is crazy. Well, let's talk about it. Let's talk about this guy right here. That guy right there. So what we're going to do is we're going to make ourselves a nice right triangle because we love right triangles. And we're going to call this our angle right there at central angle. But since we're in the first quadrant, it's also going to be the reference angle. And we're going to make it 30 degrees, which is also pi over 6. So we're talking about a nice 30-degree angle right there. And you know, with a nice 30-degree angle, that means this is 1, 2, and root 3. You know that. But what's the trick here? We're on the unit circle now. And what's the radius of the unit circle? See, the radius matches up with the hypotenuse. So what's the radius of the unit circle? Oh no, the radius of the unit circle is supposed to be 1. So instead of having 1, 2, root 2, it's supposed to be 1 right there, which means everybody's divided by 2. So this is what we're going to be dealing with now. Instead of this guy, which we got memorized, but we can still use it. But we still need to, we always just need to remember that radius is an understood 1 right there. See, that radius is going to be a 1, which is going to make that guy a 1/2, and this guy a root 3 over 2, which means my coordinates right here, which are the big deal, my coordinates, that becomes root 3 over 2, and that becomes 1/2. So there you go. You got your nice unit circle values for, well, you don't have the values yet, but you got your nice unit circle for the 30-degree first quadrant. And see, we've been doing this for weeks now. It feels like to me, we've been doing this for a while. Oh yeah, sine of 30 is 1/2. Duh. 30 degrees, the sine would be just the y value because we're on the unit circle. The radius is 1, so we're on the unit circle, so 1. So you say, okay, that's no big deal. I can do that. In fact, I would look at this and say, therefore, oh, I know my values here. Sine of 30 is 1/2. Cosine is root 3 over 2. Tangent is root 3 over 3. We've been doing this for weeks now. Cosecant is root 3 over 3. Cotangent is root 3. Now, we're also going to start thinking in terms of radians. So this is all the same for pi over 6. All the same for pi over 6. And no big deal. And here's the next thing. We're in the first quadrant. The x's and the y's are positive. Everybody's positive. So just like we've said, in the first quadrant, all 6 are positive. None of them are negative. That's what that positive negative up there at the top is asking you about. The positives and the negatives. Now, here's where it gets crazy. Everybody ready for it to get crazy? Let's go into the second quadrant. Let's make a second quadrant 30-degree reference angle. So if the reference angle is 30 degrees in the second quadrant, that meant my actual angle from the second quadrant, my reference angle is 30 degrees. So if my reference is 30 degrees, my actual angle theta would have had to be 150 because we know that the reference angle is equal to 180 minus theta. So do a little algebra. So theta is 150. And in radians, that would be 5 pi over 6. So we got to start thinking in terms of radians. And then everybody gets upset and saying, oh no, this is so different. Well, think about it like this. So that's 150 degrees, and that's 5 pi over 6. You're thinking, oh no, it's so incredibly different. Well, I would contend that it's not so incredibly different because it's still a 30-degree reference. So the sides are still the same. That's still 1/2. That's still 1. This is root 3 over 2, except, we've gone into the second quadrant, and x in the second quadrant is negative. So that's negative root 3 over 2, comma 1/2, like that. Which means, and you're thinking, oh, this is going to be impossible to memorize. It's not going to be impossible to memorize. It's the exact same value. Okay, I take that back. It's not the exact. It's the same values, except we have to change the positives and the negatives based on the quadrant. So see, I would say to myself, I don't have this memorized. Whoops. I don't have this memorized. I just know the patterns. I just know the patterns. So I'd say, second quadrant, X is negative, Y is positive. Oh, wait a second. I remember my good old all seniors take calculus, and in the second quadrant, only the sine and the cosine, only the sine and the cosecant. Sine and its reciprocal are positive. Sine and its reciprocal are positive, so I just have to slap a negative in front of everybody else. Sine is positive, cosecant's positive, so I just have to slap a negative in front of everybody else. Okay? So you're thinking, okay, this is weird. We go into the third quadrant, do the same thing over again. Go into the third quadrant, we do the same thing, except now X and Y are negative. And we've had this discussion. Oh no, X and Y are both negative. Hypotenuse is always positive. Third quadrant, that would be 210 degrees and 7 pi over 6. And we can work through that in class if we need to. Okay. But you still end up with the same ratios. It's still a 30-degree reference right there. So here's your Y value. Here's your hypotenuse, which is always going to be 1 on the unit circle. So, the Y value, sine, is negative 1/2. Wait a second. It's just 1/2 again, except it's negative because of the quadrant. So all these values, once again, are the same. I should have written this better. All these values are the same again. And the only thing that changes is who gets the negatives. Well, in the third quadrant, only tan and cotan are positive, so everybody else gets a negative. Only tan and cotan are positive, so everybody else gets a negative. So you know where I'm going with this. Fourth quadrant. So I'm thinking, okay, fourth quadrant, I got to figure out the reference angle, all that mumbo jumbo. So fourth quadrant, that'd be a 330-degree angle, which is 11 pi over 6, but the reference is still 30. So we still have positive root 3 over 2, but now the Y coordinate is the negative 1/2. So X is positive root 3 over 2, Y is negative 1/2, which means fourth quadrant, we just follow our rule again. These guys, once again, same set of values, except we're going to change based on the quadrant. And so everybody who's saying, oh man, look at this, look at all of this stuff here. I'm supposed to have this memorized. I don't have this memorized. I don't have it memorized. I don't expect you to have it memorized. I expect you to memorize the patterns. Because if you memorize the patterns, you say, okay, I know the basics here. Therefore, fourth quadrant, only cosine and secant are positive, so everybody else gets a negative. I think I did that right. Whoops, positive, that's the negative. Only cosine and secant are positive. Everyone else gets the negative. So we're just based on these values here of the reference angles, going around the circle with the reference angles and knowing our who's positive, who's negative as we go around the circle. I don't need to have every bit of this memorized. In fact, one of the things I always say is the only thing I have memorized is that sine of 30 is 1/2. That's the only thing I have memorized. Because if I know the sine of 30 is 1/2, then who's always paired with the 1/2? Root 3 over 2. and everything else follows from that. So if you know your quadrants and you know your basic values here, it all fits together. Okay. So we're going to stop right there and we'll do the other ones. I don't know how many more videos it's going to take, but I'm going to stop right there.